Well, hello, Alaska. There's a perfect spring day here in New Hampshire, so I'm fighting my urge to get out there and prune the trees. And I bet many of you are like thinking, why aren't I out pruning? So hopefully we cover some really good stuff today that makes this worth spending 2 hours here in front of a computer screen and talking with each other. So my goals today are, we'll spend about 75 minutes going through the slideshow, talking about soil biology and plant diversity in an orchard ecosystem, talking about soil mineralization, soil amendments, all the things that kind of come together through the roots to make the apples that we grow. And then I'd like to allot as much as 30 minutes to the question and answer phase. We had some great discussions last time, and I really enjoy that part because then I get to have somebody else, so to speak, in the room with me. And then if that all goes the way I have it envisioned, I have a little bonus section on foliar nutrients and some of the new stuff that I've been working on to take us out. So we'll get right into the slideshow, and you no longer have to look at me, and we'll start looking at apple pictures as soon as I figure out my thing. Okay, so like I said, this is all about prioritizing biology and diversity, the whole orchard ecosystem picture, and what I like to call the fungal duff, just because it puts our minds on really what is the central focus of what should be happening around an apple tree, and that's a fungal dominated soil ecosystem. So last time I spoke about the 5 tenets of holistic growing, and I talked about fungal stewardship and mineralization and competitive colonization and boosting tree phytochemistry, and the last piece, outrageous diversity. So you're going to hear threads of that, but even stepping back to the big picture, this is all about how to grow healthy fruit. And I'm going to show you maybe 5 slides that are repeats from last time, just because I really want to emphasize that point. And this is one. When we're growing healthy, it's all about plant metabolism. It's about the photosynthesis and the form of nitrogen that the plant combines with that carbon sugar to create, that carbon sugar and then create proteins. It's about fat synthesis. It's about having enough reserve energy to go on from there to produce the resistance metabolites by which the tree wards off disease, pathogens, and also some of the higher order insects. So I don't want to lose sense of everything I'm talking about is kind of funneled through that lens. And if we translated that more directly to thinking as fruit growers, I'm talking about, those aphids, those leaf rollers. These insects are drawn to plants that are not producing complete proteins. There are amino acids in the sap, and that's what they're feeding off of. And if we have robust metabolism, we're going to see less of that. You're going to see less insect pests. Beneficial allies in the ecosystem are there because we plant the right kinds of plants. That's another big factor in keeping insect pressure down. The whole mycorrhizal scene is about balanced nutrition, but it also plays into stimulating the phytoimmune response of the tree. It also plays into messaging throughout the plant community that makes up our orchard ecosystem. And finally, delivers balanced nutrition, which is really the basis of that whole healthy plant metabolism thing. So we're talking about that zone underneath the fruiting tree, and I don't care if your fruit tree in your mind is an apple. Maybe some of you, maybe somewhere, no, probably not peach, you're like me, have the plum or the pie cherry. But we're talking about that ground where the permanent root system of the tree can be found. That's primarily within a few feet of either side of the drip line. We're talking about managing that zone as a fungal duff. So diving into the fungal piece, it, for me, really starts with that word mycorrhiza. And myco, that's the Greek root for the fungal kingdom. Rhiza would be the root system of plants. And that tells you a whole lot because it's the two together. It's not just the fungi in the soil. It's the fungi interacting with the roots of plants, where all the things that happen through symbiosis, through this mutual partnership, take place. And you can't have one without the other. You can have fungal spores waiting for a plant friend. You can have plants grown in a sterile medium in a greenhouse that don't have plant friends, but it's only when you bring them together that magic happens, what I call magic. Another repeat slide, just because it's so important. This is our team, what's called the soil food web, the actinomycetes and the bacteria, the saprotrophic fungi that break down organic matter, the mycorrhizal fungi that interact with those organisms and get those nutrients to the roots, the predators, the protozoa, the nematodes that consume the smaller microbes, thus releasing nutrients, some of which are absorbed by the tree. And again, it's our team, and our main job is not to screw up our team. So mycorrhizal advantages. Just having good organisms in place means that there's not an open niche for troublesome organisms, the ones that cause disease. We're going to look a little deeper into that whole notion that you have a root on your fungi, and then you have hyphae reaching out, so they're accessing more soil volume. But it goes on and on. There's a multiplier effect here. And all of that means more nutrients are accessed. That means better plant metabolism. I have a slide. We're going to talk about how plants and fungi communicate throughout the ecosystem. As far as disease is concerned, the more we can boost inner phytochemistry on the plant, the more we're not talking about fungicides, the more we're not having problems. That doesn't mean it's not a really, really wet year and we don't need to do some nudging, so to speak. But it's going to be handled from within, and that is so much better. When all those things are happening, you have an ecosystem that is that much more resilient. And then the other gift of the fungi, particularly what are known as the endomycorrhizae, and I'll explain that in a couple slides, is that this is the principal way that carbon gets sequestered down in the soil. So our little dance with apple trees and other fruit plants and fungi in the soil, that's a really key part to how the earth keeps things in balance. So last time I just very briefly introduced to you the two major types of mycorrhizal fungi. The first are the ectomycorrhizal fungi. These are the ones that are associated with trees of the forest. So not so much our fruit trees, but the deciduous trees and the coniferous trees that make up the forest. And these are ones that we can see with our eye. So when you scratch into the leaf litter duff in the forest floor and you find fine roots, you will see that fungal mycelium. It almost fits across on those fine roots like a tight glove. And this was the first that humans became aware of, again, because we could see it. The other thing that we can see about ectomycorrhizal fungi is they're the ones that form fruiting bodies, mushrooms. So if you gather chanterelles or boletes or matsusakis or whatever secret spot you have to find wonderful mushrooms, they're affiliated with a particular tree species that the fungi have this union on their roots. And then I'm gonna really draw on the fact that these are the mycorrhizal fungi that can go a good distance. And by that, I mean like 12 feet. But when you're a hyphae searching for mineral, 12 feet makes many things accessible that otherwise are not necessarily going to be there for the other fungi. So ectomycorrhizae evolved from rot fungi, decomposition fungi, about 160 million years ago. They reproduce asexually. That's why there's the mushrooms. The other grouping are the endomycorrhizae. So that preface, ENDO, represents the fact that these are the fungi that actually penetrate into individual cells in the root, where they form nutrient transfer mechanisms that are known as arbuscules. We looked at a picture of those last time to make this exchange of carbon sugars to the fungi for minerals from the fungi to the plant. And the endomycorrhizae affiliate with about 80–85% of the plants on Earth. So almost anything we're going to talk about, from fruit trees to grasses to red clover to willows to raspberries, are going to have this affiliation with endomycorrhizae. And when you have that connection in place, bringing balanced nutrition, that's when you start to grow more nutrient-dense fruit, which is important for our own bodies in terms of our health. Endomycorrhizae, because they actually penetrate into the root cell, that acts as a tickling signal to prime the phytochemical defenses that plants create to ward off disease. So in a sense, just having endomycorrhizae as part of your soil ecosystem associated with the fruit tree means that things are in preemptive gear, so to speak. And then finally, this notion of passage plants, I want to explore that a little bit more. When I talk about fungi affiliating with, let's say, a tree root, that's one single interaction. But when that same fungi has an affiliation with some of the plants in your understory, we're now tapping into other photosynthesis systems, roots and fungal hyphae that are reaching nutrients that maybe our tree are not. And then when we start to understand that these endomycorrhizae have multiple affiliations with all sorts of different plants, so that multiple fungi are affiliated with the same plant, and then start to realize that everything that's being shared here is really the protoplasm, the sap of the plant, the cytoplasm, protoplasm of the fungi. That's where this nutrient exchange takes place. And everything has this gook, this inner sap, this inner protoplasm. And so now you start to get the sense of how we can extend all these mycorrhizal advantages through fellow plants that form an integrated plant community. You know, this picture shows the root of a little pine sapling, and it's more brown. And then you see the fungal hyphae extending from there. So that's an ectomycorrhizal fungi. But either way, you get the sense that the solid root, in and of itself, only accesses so much soil. But the hyphae, the mycelium, starts to access 100 times more. And when we get into that whole shared protoplasm factor in different plants in the community, what's known as the common mycorrhizal network, that access extends over acreage. And again, that's where the magic happens. Now, there are a group of plants, what are known as the so-called soft hardwoods. So here I'm talking about things like willow and alder and popple, birches, soft maple, a lot of species that are here in northern New Hampshire that are also kind of probably fairly dominant where you are. These have affiliations with ectomycorrhizae, but also endomycorrhizae. So this is where two entirely different fungal systems come together to share that protoplasm. And when we add in that piece of ectomycorrhizae having that long explorer hyphae, by virtue of having these plants in the vicinity of our orchards, and I'm not saying they're right next to the apple tree, but in the vicinity, within a few hundred feet with other plants in between, we start to be able to bring some of that action from minerals from bedrock up into the other plants, some of which is going to reach our fruit trees. So the whole idea of polyculture from a fungal perspective suddenly just enlarges this picture of nutrient sharing throughout the mycorrhizal common network. Plants will dedicate as much as 2/3 of sugar production, that glucose and other sugars that plants produce through photosynthesis, to send directly down to the roots at peak points in the growing season to share with the biology. Now, some 30 to 40% is going to be directed to mycorrhizal fungi. The rest is going to be directed to bacteria because they're an equally important player in the dynamics of what's going on in the soil. Mycelium messaging, it can take the form, it looks like this. This corner of the orchard, maybe the soil is a little wetter, whatever reason, the tree is doing not quite as well. It's not quite as robust, and it has attracted aphids. And so you have these aphids, which the plant tries to both repel through phytochemistry, but that same kind of signal goes down through the roots and it travels throughout the mycorrhizal network and reaches other trees who, in response, start to produce volatile exudates in their leaves, not to necessarily repel aphid feeding, but to call in the beneficials the ladybugs and the civet fly larvae that are going to take care of the aphid problem when it arrives. And that happens to this whole fungal networking, which incidentally has nothing to do with Clint Eastwood, but that's just a good picture for this slide. One of the things that mycorrhizal fungi do, and right now I'm specifically talking about endomycorrhizae, which are the predominant ones, is in the hyphae moving out and exploring through the soil, it gains rigidity from this protein substance called glomalin. And hyphae, like roots, have kind of an ebb and flow to them. So at different points in the growing season, this zone of soil has been, let's say the phosphorus has been utilized. So now they move to this section of the soil. Well, when hyphae retract, they leave behind that glomalin. That glomalin is also used when fungi essentially glue together fine particles of silt, sand, to form soil aggregates. And glomalin is made up of somewhere between 30 and 40% natural carbon. So this is the main method by which humus is built, by which long-term fertility, by which carbon is stored in the soil. It's happening because of the work of endomycorrhizal fungi. So fungi carry forward into future growing seasons and also extend in the season at hand by three different ways. One is mycelial anastomosis. That's the fact that fungal hyphae of the same species will fuse together. And as they reach out, they find new plants. That becomes a new center. The reach is now further and further. Root fragments is highly relevant to gardeners. To know that your tomato plants, your garlic plants, your pea plants, if you don't yank out all those root systems, that's the primary way that fungal hyphae overwinter in those root fragments to then be in place to colonize the plants that you put in that garden the next year. So that's for annual plants. With our fruit trees, orchards, perennial systems, we're not so much thinking about root fragments. And then finally, throughout the mycelium, in those root fragments, sometimes really tight onto the hyphae themselves, the fungi sporulate. And those spores will find new plants to connect to in a subsequent growing season. They're going to live several years in the soil, but that's also something that we can cultivate. And this is where the whole idea of commercial inoculum comes into place. So if I were to tell you about a couple reputable companies, I certainly would mention Mycorrhizal Applications. Bioorganics is closer to me here in the east, there in Pennsylvania. Mycorrhizal Applications is in Oregon. But these are companies that put multiple species together. So you'll see different mycorrhizal products. I'm going to get into this in a minute. But diversity is one of the goals of going to the trouble of doing this. So whenever I plant a fruit tree, whether I bought rootstock from a commercial nursery or I bought a bare root tree from a nursery, very often those root systems do not have an association with mycorrhizal fungi, on top of which a bare root system doesn't necessarily have a lot of soil clinging to it. So I take advantage of that point in time and use the mycorrhizal root dip that I get from bioorganics. It doesn't have to be a dip with the hydrogel. This is just my little moment with the tree, so to speak, where I can pretend that I see the mycorrhizal aspect, but it's really the hydrogel. But I take advantage of that because I want to get that tree off to a really solid start. It is true that over the course of time in undisturbed soil, roots from other tree species from other plants are going to interact with those apple roots, with the fruit tree roots, and introduce some of the indigenous organisms that are in your ecosystem to that. But on the other hand, especially depending on how we prepared the soil, and if we shifted gears and changed ecosystems and took out a softwood forest or what have you, and there was heavy equipment involved, there's probably not a whole lot of the right kind of mycorrhizal fungi in that soil. On the other hand, you can also grow out endomycorrhizal spores by taking native soil from a healthy ecosystem around healthy looking plants where their roots are, and putting that in a sack, fairly large volumes of soil, a couple cubic feet, and planting grasses like annual rye or Baha'i grass, which in going through the season form an affiliation. Grasses are being picked because they're known for many multiple affiliations. After about 3 to 4 months of growth, as those grasses start to die back, either due to cold or lack of water, or just simply being cut way back, the fungi are going to sporulate, but they're going to be contained in that sac. And then that sac becomes a source of hundreds of millions of spores that you might utilize. Now, that method, you don't know who's who, but that's, in truth, we often don't know who's who. In these commercial formulations, we know a little bit about that. This is what I call the core 4. And you're going to find these 4 species at a minimum in any reputable mycorrhizal spore inoculum. I like to get the products that have 7 or 9 different endo species, of which 4 will be these. But when you look down this list, Glomus enterodeces is the one that if you get a fungal inoculum that has just one type of fungi in it, that'll be the one. And it has very tiny spores. And so that product will probably claim we have so many spores per cubic centimeter. That's because they're very tiny. They can do that. But you really want diversity. If you're going to this trouble, you want to get that diverse aspect into the mycorrhizal package. Glomus massae, and there's about 4 in this category. One of the things they're noted for is the ability to move water throughout an ecosystem. So if there's a drier portion of your land, you should still be thinking about irrigation, and particularly in really dry times, particularly for young trees. But you can also know that I've got some mycorrhizal helpers down there that are moving water where it's needed. And that's a species that does some of that. Glomus aggregatum, one of its skill sets is being able to break into more compacted soils and open things up. So if you're dealing with a clay soil situation, that's probably somebody you want on your team. And Glomus etunicatum has a lot to do with volatile oil production and things that are more relevant to herbalists. But you get the idea. We're looking for diversity in our fungal team. Now, this is a list put out by Valent, which has recently bought mycorrhizal applications, just listing some different skill sets of what mycorrhizal fungi might do. You know, one I'm highly interested, I made in blue, the 3rd line down. Enzyme activity increases micronutrient uptake. And you see that 3 of the 4 of these, through research, through studies, have been noted to do that. So when we get to talking about micronutrients, trace minerals, I'm very much relying on the fungi to do part of that work. But again, now from the perspective of skill sets, you see, we want all that kind of action going on. And when you have more than 4 fungi, you start having 7 or 9. And in a healthy ecosystem, you'll have as many as different 50 fungal players working for you. That's more and more skill sets doing good plant things. I guess this slide is a little more relevant this is relevant for us. For annual plants, I was going to say, because those fungal spores have to be put close to the roots. So you get the idea when I'm dipping it in that hydrogel inoculum, that spore is being put right there in the vicinity of the root where the chemical signaling from the root is going to launch the colonization process. Similarly, if you're already planted your trees and you're thinking, you know, maybe I have to dig them up and dip them in this stuff he's talking about. It's like, no, what you need to do is scratch away 1 inch or 2 of the mulch, the topsoil, to where the roots are going to be found, and either put that spore powder, or maybe it's even a quart cup worth of soil from a healthy ecosystem where similar type plants are growing, like a forest edge. Not just trees, not just apple trees, but you know, these are family groupings we're working with. but you want to get that inoculum close to the roots. And yes, the roots are going to be reaching out and they'll find them, but you don't want to be way, way out there. And you also want to make sure that it's covered back up by the fungal duff, by the leaf litter, by the topsoil, because these are soil organisms. Endomycorrhizal spores do not hang out on the surface of the ground. This is something that's underneath the soil surface. So I just want to briefly tackle this question of, am I introducing an outside fungal organism that really has no place in my ecosystem? So when I talk about these inoculum products with 7 or 9 different endomycorrhizal spores, we need to understand as humans that back when our planet was a water planet 450 million years ago, and the oceans started to recede, left behind in the tidal pools were the ancestors of vascular plants. Think of that as like algae, and also oceanic fungi, whose filaments were able to absorb nutrients from the water. And as the tidal pools started to dry out, the oceanic fungi and the algae made a deal. And they made a deal that the fungi would bring nutrients to the plant, who was going to evolve into a full-fledged vascular plant. And the plant, in turn, was photosynthesizing and could share energy in the form of carbon sugars with the fungi. Well, this was such a perfect union right from the start that the whole endomycorrhizal realm over the course of hundreds of million years since, there's only like 400 species of these fungi working with some 250, 100,000 plants worldwide. And fungi that we'll find in the tropics or the savanna ecosystem, the temperate forest, the boreal forest, are the same players. They might have different skill sets, but it is very likely that most, if not all, of the species in those commercial inoculum products, because they've been deliberately selected, understanding this, are going to have a place in your ecosystem. And if they are from a different ecosystem with a slightly different skill set, through horizontal gene transfer, and also the fact that hyphae of the same species can fuse together, essentially, this is grafting, fungal grafting, they can pass that skill set on and in effect make your fungal ecosystem just a little bit more thrifty in terms of what it's able to do. So from the perspective of fungal adaptability, there's a lot of leeway here in terms of working with species and knowing that they're going to get the job done. It is important because we're talking fruit, and I think probably many of you grow blueberries just like I do, to understand that blueberries are in their own category. And the Ericaceae, the acid-loving plants, have a third type of fungal connection, and that's through the Ericaceae mycorrhizae. And these are not endo, these are not ecto. They're kind of like it, but they're different. And these are species that don't necessarily come with your blueberry plants, your blueberry starts, unless they're in a peat moss type environment, because peat moss, 9 out of 11 samples, will have spores from long before that are waiting dormant in that peat moss. So I just point that out, that if you have blueberries and they're not quite taking off, you might try a new batch of peat moss just to supplement that soil. And or you might use the trick of going into the wild where acid-loving, maybe they're blueberries, maybe they're cranberries, but acid-loving plants in the Ericaceae family are growing and bringing some of that soil back to where your blueberries are. You know, one of the things that I learned when I think about the fungal realm, when I think about plants interacting with fungi, is, you know, we as humans have this idea that life is a pretty competitive affair. And it's very easy for us to take that notion, that experience, and say, that's how it must be for plants. And so that, you know, that's where the whole notion of planting apple trees in an herbicide strip so there's no competition comes from. Whereas nature is teaching us that it's through cooperation, collaboration, that support networks work together to make good things happen in life. Back in the day of Rachel Carson, there was an ecologist named Frank Egler, and he said, nature is not more complicated than we think. Nature is more complicated than we can think. And I like that. I'm very humble in the face of all this beauty of the soil organisms and green plants photosynthesizing, that I know a little piece of it. And I know my job is not to screw it up. And I know that if I'm really blessed over the course of my lifetime, I'll learn a few more little pieces of it, but I'm never going to know the whole thing. Nature is really, really intelligent. And to work with that and to trust that is probably a really important first step in becoming a successful holistic fruit grower. But meanwhile, back here on the surface of the earth, in our bodies, perceiving with our senses, I like to tell people, you're probably doing things right if you see some mushrooms pop up now and then. So this mushroom here is not a mycorrhizal species. It's not an ectomycorrhizae with a fruiting body. It's one of the saprotrophes, many different species of fungi that decompose organic matter. But that's an action that we want. And it's a reflection of us very likely providing the right forms of organic matter for our trees to thrive, that occasionally we see some mushrooms, which to me is just kind of a badge of honor, so to speak, in that I'm doing something right. I may not know what I'm doing, but I'm doing something right. So let's talk about a couple ideas that are in vogue that have a lot to do with establishing fungal connections. And here I'm stretching them. This is not necessarily just mycorrhizal, but also kind of the saprotrophs, the decomposers. But it's all one and the same piece. So this notion of hugelkultur, which comes from the permaculture folks in Germany, Austria, Sepp Holzer is one of the names associated with hugelkultur, is the idea of burying woodsy debris to decompose through fungal action, to hold moisture in the soil, to act as a long-term source of minerals as lignins and cellulose breaks down. And that can take the form of burying and making raised mounds. You can utilize big wood as well as branches, little wood, in doing hugelkultur mounds. It can be freshly cut. It can be already starting to decompose. A lot of times if you're clearing ground to establish an orchard in a more wild place, you probably are dealing with woodsy growth. And rather than burning it and being left with a small pile of mineral ash, it may be suitable to work with creating swales across contour, terraces, to do your planting. And it may not, but this drawing here kind of shows the two typical approaches to doing this. In the bottom picture, you see the hugelkultur mound with soil from above thrown across the top of it. And take this in context. You don't want to form a dam totally across a slope. You got to have openings for soil, surface water to move down the slope. But you want to catch some of that water. You just don't want to create a solid dam. But anyway, in the movement of that soil from the ditch on the uphill side to cover the wood, you create a slight swale, which is going to be helpful in collecting moisture. That swale, in turn, can be filled with chipped wood as another means of building soil on the uphill side of the tree. But what you're doing is taking advantage of a woodsy resource, utilizing it to hold moisture on your slope, and you're creating a fungal duff on both sides of that tree. Other plants can grow in this medium. They'll get established in time. And to me, that's just a really beautiful way to integrate many different needs at the same time. This is what I call extreme hugelkultur. This is my friend John Bunker in Maine. John is the one who started Fedco Trees. Some of you may have seen that tree catalog. And he cleared an acre of mostly softwood, not ideal fruit ground. And he used all those treetops to form a huge hugelkultur mound in the middle. And the trees themselves are planted on the outskirts of this, not planted on top of that, because it's going to be a while till that breaks down. But he's just created essentially a huge banking of organic matter that 10, 15, 20 years from now, those apple roots are going to be tapping into and relying on for nutrients for a long, long time to come. Now, another thing that many people talk about is the notion of biochar. So here we have some form of carbonized wood, carbonized grasses, and it's in that carbonized crystal structure that biochar is really adept at drawing positively charged cation nutrients and holding them there in reserve. So in that sense, it acts like a rechargeable battery. But the thing to know about biochar, and I like to throw some embers after I sift the ashes from our wood fires into my planting hole. It's kind of like a rechargeable battery to get a tree started, so to speak. But the thing to know about biochar is that it's operated, those nutrients are accessed principally by mycorrhizal fungi. So in this picture, I'm going to call it on the right, but where you see that it's a bean root sticking down, and then there are root hairs on the lower part of the screen coming off of that main part of that feeder root. That's all pretty blunt. And when you look at the biochar particle over there on the other side of the screen, those crystalline pore spaces are very fine. And what this picture is showing is the finer thread-like filaments that you see, those are mycorrhizal hyphae. They're the ones that can penetrate into that biochar and make that rechargeable battery work. So just throwing biochar down in a non-fungal ecosystem isn't going to actually do much. You get this idea that you have to understand a little bit more to make yourself dangerous. Fungal foods. Now we're going to talk about organic matter, particular to fruit tree ecosystems, and particularly emphasizing soluble lignins, which really give fungi a jump start, really get things going in the direction you want to go, biologically speaking. So back when I showed that picture of the soil food web, the words on the screen were mineralization and assimilation. And that's all about microbe eating microbe, releasing nutrients, some of those nutrients going back into microbe bodies to be stored until the next microbe eats a microbe. But if you take it a step further, there are organisms that produce humic materials, and the building of humus, long-term fertility, this is what we get from Eastern, I say Eastern, but actually in talking with Darren before today's talk, coming out of a glacial time, this is one of the players involved in building long-term humus. So just as I have a thin soil here in New Hampshire, you have thinner soils in Alaska. You know, we certainly want to tap into this whole idea of humification because that's where long-term soil fertility is built. And so I often, in these workshops, talk about the concept of ramial chipped wood. And the word ramial is a French word just indicating the smaller portion of the tree. But if you look at this picture, you see twigs, you see the ends of chips and that green cambium layer exposed. Those are the soluble lignins. That's where the mineral nutrition is stored. And ramial wood chips have kind of two features I want to emphasize here. One is that in a tree, the majority of nutrients the nutrients are stored in the cambium, but the majority of the cambium cells are in the branches 2 inches in diameter or less. So it's really the tops of the trees that are a whole lot more nutrient rich. Another thing about the tops of the trees is the carbon to nitrogen ratio is going to be anywhere from 40-to-1 to maybe as much as 70-to-1 at that 2-inch cutoff point. And plant ecosystems, orchard ecosystems can work with that. When you get into bigger wood, the carbon to nitrogen ratio jumps 300-to-1 to as high as 700-to-1. And all that carbon is going to lock up nitrogen. That's not what we want. We want that smaller portion of the tree. Then the other thing to understand about the ideal wood chip for building soil fertility, soil tilth, working with fruiting trees, is going to be deciduous in nature and not coniferous. So deciduous meaning they lose their leaves once a season. These are the hardwoods, but also those soft hardwoods I was talking about that act as bridge trees, but not trees like spruce, pine, fir that hold their needles. And the difference is that deciduous wood has two types of lignins that are broken down by decomposition fungi that I'm going to call the white rots. It's the white rots that are the prime players in making humic substances, storing, stashing that long-term fertility. Softwoods, the coniferous species, have one kind of lignin and a whole lot more cellulose. So that material is broken down by decomposing fungi that I'm going to call the brown rots. And the brown rots, in the process of first decomposing softwood organic matter, produce allelopathic compounds that inhibit the growth of deciduous trees. So the very exact thing we don't want to put around a young fruit tree if we're mulching it completely is fresh softwood chips, because it's going to go through this phase of decomposition that's going to hinder the growth of what you just planted. So if I'm getting chips from a softwood source, they're still quite useful, but I need to age them. I might do that through a composting process. I might use them as animal bedding. I might use them on the blueberries because that's a slightly different ecosystem. But I'm not going to put them out fresh under the tree. Now, once you get your trees established and they're bearing and they're bigger, and we'll talk about haphazard mulching here in a minute, that doesn't become quite as big of a concern. But ideally, the chips that you're dealing with are going to come from deciduous trees because that's going to build the best soil in the long run. And all of what I've just described is totally different from bark mulch and sawdust. If you can get hardwood bark mulch and that's your only choice, that has a whole lot more value than softwood bark mulch, which is what's typically ground at the landscape centers, at least here in New England. And softwoods just have a whole lot of tannins in them, and they're just really not something that's going to encourage a bed growth. And yeah, I like mulch and keeping weeds down, but we're not talking mulch in that sense. We're talking about fungal food. So keep that dynamic in mind when you're thinking about this concept of ramial chip wood. This is a picture of a Wallenstein chipper that I have that I operate off my 3-point hitch of my tractor. And I use that to chip branches in the orchard after pruning season. But I also manage the surrounds of my orchards where it's more willow and alder. So I want those root systems, but I will chip it. And you can see it looks quite twiggy. This is not a chipper shredder, but that's okay. My guiding principle here is that I want to emulate the forest edge, and things are not all shredded and nicely manicured on the forest edge. It's a little wild. It's going to break down over time. But I love the whole notion that through the use of this chipper and management of orchard edges, I have a homegrown source of the ideal tree food for building long-term fertility in soil. And I bet a lot of you have access to this as well. And the chipper is not the key piece here. I wanted to show you this picture. So again, we prune an apple tree. We're pruning small branches for the most part off of a deciduous tree. And I will chip the larger branches, but often as I work, I don't want to go pick up every water sprout again or a smaller branch that just doesn't have that much to it. I'd rather just make sure I cut it enough so that it lays flat. Now this is an important distinction. I'm not throwing branches willy-nilly, long branches, whole branches, crooked, sticking up in the air branches down under the tree. I'm doing it so that it lays flat, and it's going to be decomposed by more or less a soil environment rather than an aerial environment. I also, I put word out to the companies that clear under power lines. If you come here, you either get a 6-pack of beer or a nice bottle of hard cider. And if you're involved in a bidding war with another fruit grower who lives a mile down the road, you might be talking a case of beer or 3 bottles of hard cider. But still, a pile of that size is certainly worth that. And sometimes if the timing is right, that goes right out underneath the trees. Sometimes if it's going to sit there for a few months, or maybe has a little bit more softwood than I want to put out around young trees, I'll appreciate the fact that it's going to sit there several months. And I might even stick like wine clap inoculum or some other kind of edible mushroom species here and there in that pile so that the mycelium grows throughout it. And then when I make little piles out in the orchard, I'll see things like oyster mushrooms or wine caps coming out in the orchard. It's kind of an erratic approach, but it's also an opportunity to create another food resource in your system. So some of you should be asking the question, well, what if the wood that I'm pruning out is diseased? So fire blight is one consideration. And if we were talking fire blight just before green tissue shows and it was actively oozing, I would want to get that out of the orchard. But probably the disease I'm more talking about is black rot. And black rot, it gets into a tree. It may be where a pruning stub was left a little too long. It may be where the power line company went and gave it kind of a haircut all at laser line level, but that meant all kinds of stubs that didn't heal properly. Black rot gets in there, the wood starts to rot in that aerial environment. It sporulates, cankers form on older branches. This can become a real issue in longer established orchards where you start to lose some of your principal scaffolds because black rot got in there. That's where I really want to make sure that things are going to be decomposed in that soil environment. So if I chip it, I've taken away the aerial environment. When I cut little branches into twigs and they lay flat, I've taken away that aerial environment. And black rot gets established. You'll see a disease called frog eye leaf spot, and it has kind of a tan spot, and it'll have more of a less purple edge, and that center part can actually fall out. That's black rot, which in a couple of years, if it gets a stronger hold on both the leaf, and there's a little fruitlet showing in that leaf picture, those little mummified fruits, they're the source of black rot for the following season. So again, just from the perspective of diseased wood, if you change the decomposition environment, you change the prospects for that disease carrying forward. We can talk about that more in the questions and answers. So here you see how I mostly apply radial wood chips. I have my tractor, I get a bucket full, I go and distribute that bucket full in usually 2 different spots. It's kind of random. I'll do one side of the tree one year, another side another year. And what I'm basically doing is creating different age pockets of decomposition. So roots can kind of have a salad bar, a fungal salad bar, choose where they want to go to get what nutrients, but have different places. And I'm never totally trying to mulch the tree entirely because I don't want to break that affiliation with other plants, which is helpful to that whole mycorrhizal network thing I was talking about. I'll also utilize the spots where I have dropped mulch to plant things like comfrey. And we'll talk about different plants in a minute. But this is a tree I consider under cruise control, so to speak, in that the comfrey is growing more or less out in the drip line. It's more open underneath the tree. I don't mind dandelions. They're accumulating potassium. We'll talk about that part as well. But it's more open, but it's also woodsy. There's fungal decomposition happening, but the comfrey in turn is helping keep the grasses a little further out. The structure of the tree as well, through shading the ground, is keeping the plant cover not quite so dense. And you get a real appreciation for the fact that in that soil, there are competing roots. Again, I use that word competing in quotes, that there's still plenty of room in the humus for apple roots and apple mycorrhizal fungal friends. And it does truly become more of a cruise control situation than those early years of trying to keep it a little more open around a young tree. So fungal duff management, a number of ideas here. The whole notion of mulching haphazardly, you're emulating the forest edge. You're having different places for roots to go to find different things. when I do my holistic sprays and I include the liquid fish and the neem oil, the Karanja oils, I'm primarily using those materials for their fatty acid content. And those fats fuel fungal connection and are, kind of like a high dollar food for the soil biology. So that fits my idea of what I do supporting the fungi in this fungal duff. Totally different scene than spraying fungicides that are designed to kill fungal species. Yes, disease lands on the leaf, you spray the leaf, but the fungicides drip to the soil. And there, those fungicides have activity against saprotrophic species and mycorrhizal species. You're not doing a fungal duff management, you're not achieving your goals by that choice of spray material. When I get mulch hay, farmer has a field of hay and there's a late afternoon thunderstorm. And so now the hay doesn't have value for animal feed. And I bring back a pickup load of mulch hay. I don't go and spread it in a compost pile or as mulch around trees. I actually throw it out there as whole bales. And I do that because that fall, I know that mice are going to nest in that bale. Mice are not voles that are going to eat our tree bark. But even if voles go into those whole hay bales, they don't put it right up against the trunk. But come spring, when you hear that first glorious kind of low thrumming buzz crossing in front of you, that's the bumble queen awakening. And a bumblebee favorite nesting site is an abandoned field mouse nest. And so I get a year where those bales become like a prime bumblebee habitat, very important for pollination. And then that fall, I'll break them apart when the bumblebees have gone back, the queens have hibernated in the ground somewhere. And it's pretty decomposed at that point, and it has value as organic matter. Not as high of a value as the lignins from the wood chips. And I'll also utilize things like sheetrock scraps as a builder. Sheetrock is calcium sulfate, that's gypsum. And we're going to talk about gypsum, but I always hated taking those sheetrock scraps to the transfer station when I knew that to buy them in the bag cost me so much money. This doesn't mean I go and lay out whole sheets of sheetrock under the orchard. But when I put out the scraps, that's often where the old hay goes over, unless I have some wood chips to throw over. I don't want to look at it, but I want to take advantage of that. And again, just while I'm talking sheetrock, this is not green board that you use in a bathroom because it has mildewcides in the paper. This is just basic, regular sheetrock treated with a little boric acid to prevent fires. Boric acid, boron, that's an essential trace mineral, and a little bit haphazardly laid here or there doesn't radically alter your soil. Another thing we do is all kinds of medicinal herbs, drying first-year raspberry canes for tea herb, and they're in the drying tunnel for a day. I have a wheelbarrow load of raspberry canes. I'll take that and I'll just dump it in a low spot out in the orchard. With cane prunings, you'll hear advice, oh, you better burn those. You better get rid of those because they might carry over virus. Well, I take care of that by throwing some soil or old hay on top of the canes. I've created a soil decomposition environment. I've shifted that aspect. And now I get lignins being returned to the soil in my orchard. You get the idea. There's many ways you can tie into the things that you are mowing, the things that you're fighting to keep the wild from coming into your orchard, different ways to utilize these plants. And all of that for me falls under the banner of fungal duff management. So here's a ornamental crabapple down below our garden. There's raspberries above it. There's rhubarb. Rhubarb is not a mycorrhizal plant. On the other hand, it does well in partial shade, and it has big leaves, which means those root systems, relatively speaking, don't fully occupy their soil volume. That leaves room in the humus for the apple roots. And then my wife Nancy grows peonies and dries the flowers, which have a connection to certain beneficial insects. But anyway, here we have more kind of a landscape look. than you're going to see in my orchard, which is more of an orchard meadow ecosystem. But again, there's fungal duff principles at play around this fruit tree. And whether you're planting full-sized seedling trees or dwarf trees, this notion that from the drip line down, extend that out a couple of feet to either side, manage that as a fungal duff in all these different ways we're describing. Here's a picture of bud 9 rootstock in a garden setting. So you don't have to grow the dwarf trees on a trellis. I'm using steel garden stakes here to give the tree enough support because it has a weaker root system, so it needs some support, especially under crop load. But I am managing that 3-foot strip more or less as fungal duff, though I'm actively working my garden, and sometimes that involves tillage, sometimes that involves cover crops further out. But it kind of correlates really nicely because when for instance, you harvest the garlic, you harvest the peas, you harvest potatoes. Come August, the ground is open. You plant oats and tillage radish and field pea or some mixture of cover crop that's going to winter kill. Now you have this beautiful organic matter place for the feeder roots when springtime comes, the fruit trees to reach. So it's kind of a hybrid approach, but being in the garden with dwarf trees, it works better than a chemical approach to achieve biological goals. Here's a young tree planted in a meadow ecosystem where, I have not gone and tried to totally convert what was there. There's good plants there. There's good mycorrhizal fungi there. But I want to create a place where my tree doesn't have to compete as much immediately in its young years while it's growing wood. And in this instance, I'm utilizing Ramio wood chips, some cultivation on the backside of the tree. But and then I'm going to enlarge that over time, and I'll have a little bit more control when I plant comfrey and other selected plants into the wood chips once they've decomposed. I'm creating the right kind of ecosystem, kind of from a wild scenario to start. But again, it's all about tying it to these notions of the fungi. So I did provide a handout of this fungal curve. This was in the Holistic Orchard book, and what's going on here is I am being aware of what the growth stage of the tree is and what's going on with its root system underground, and recognizing certain fungal activity taking place at different points in the season, which kind of give me a sense of when I should do things. So early spring, buds swell, you see that first popping of green tissue, and down below in the soil, it's still rather cool. It's a sleepy place. The permanent root system obviously is there, but the feeder roots are just starting to think about it. And the mycorrhizal fungi, they're there. There's spores, there's hyphal fragments. They're just starting to kind of colonize, connect with the feeder roots as they're starting to come out. And that action's really not taking place. On the other hand, early spring, when I do a ground application, I am applying liquid fish in part to help decomposition, because that's where scab and some other leaf spotting fungi diseases overwinter on the fallen leaves. But even more than that, included in my tank mix are things like raw milk. In 100 gallons, it would be like 2 gallons of raw milk, 2 quarts of blackstrap molasses, 4 gallons of activated effective microbes. The microbe piece, it's not just organisms, it's also organic acids and enzymes that in the process of activating are going to stimulate the biology in my soil. And it's only recently that I've come to understand I'm not so much stimulating the mycorrhizal fungi at this time. I'm stimulating what I'm going to call the mycorrhizal helper bacteria, whose enzymes and organic acids are going to help solubilize nutrients that the mycorrhizal fungi are going to take up. Anyway, the point is, that's some action you want to get going in early spring. So here on the fungal curve, you see apply pulsing agents. The red part of the curve, in one sense, we could say that is the rising of disease organisms, apple scab, black rot, cedar apple rust in southern New England. There's many different selections, choices we have. We could think about that as a problematic time of year, but this is also the time of year when the soil food web, the organisms down in the soil, arise to form that competitive environment I talk about. One of the reasons I spray effective microbes in the tree itself, to thwart disease by having good guys in place. So that's the whole spring season, from pink through petal fall till about a month beyond, where I'm thinking about disease coming up, but also competitive colonization is really important to me. You see here that flowers are happening in that middle tree, and on that third tree, fruit has set, and an interesting thing happens. Shoots have grown on the order of 2, 3, 4, 5, 6 inches while flowers were out. But when fruit sets, the tree actually really kicks off a spring feeder root flush, which is taking up nutrients, which are going to be used to grow this year's fruit and also form next year's flower buds. But that shoot extension stops for a period of 3 to 4 weeks. And it's not something we notice on human time, but if you really, really pay attention, you will notice. And that's because the tree is investing energy to grow that feeder root flush, so it doesn't do the thing above. And it is at that point, at fruit set, that I like to come in and sigh around the tree. And I'm going to talk about what biological mowing really means in a minute. But that's what's indicated here on the fungal curve. We come into summer, and after about 3 to 4 weeks, right after the bloom period, that spring feeder root flush falls away. All but 10% of it disappears because those shoot growth resumes up top again. And through the summer, I want that shoot growth growing fully robust. I make fermented plant extracts. I'm making sure I'm getting the right nutrients there to maximize photosynthesis. And meanwhile, the green curve, the mycorrhizal portion of the picture, comes into August, into the harvest months. And somewhere in August, the shoot growth stops, the terminal bud sets. That's very important for winter hardiness, but it's also indicative of the fact that action is no longer happening up top. That means something really important is happening down below. This is the fall feeder root flush, which is going to go on all throughout the harvest season into under snow cover. And what you see here for my tasks, so to speak, in the fall, this is when I want to make sure that I call it stirring the biological stew. But part of that is throwing compost, because I want those nutrients to be utilized by feeder roots when they're gathering nutrients, which is going to pop next spring's buds. But this is also when I want to make sure I start decomposition action so disease doesn't carry over. And you get this sense of like there's a pace to what we do at certain points, but it's not based on our whims. It's based on what is the tree doing, what are the fungi doing, what are the bacteria doing, how can I work with that? How can I tie my actions to making tree health the priority? So this will be like a short, sweet little sidebar on biological mowing. So going back to that spring feeder root flush, it's going to last 3 to 4 weeks. If during that time I can pulse the mycorrhizal energy, the root energy, more or less totally in the direction of the fruit tree, that means I need to knock back the meadow grasses, the clovers, the herbs, the wildflowers, right in the vicinity of the fungal duff. So this is when I like to come in and do that spring mowing. And in this case, I mostly work with a scythe because I have very steep ground. If you had flatter ground and you had enough trees to justify it and had a small side-mounted sickle bar mower, that would be another way of achieving this. So I'm not mowing the whole space. I'm mowing that area right around the tree. And by knocking back those plants, that gives a shock to their root system. They reseed. This opens things up more for the feeder roots of the fruit tree, but also the mycorrhizal fungi that are associated with the feeder roots of the fruit tree. I'm also knocking down that plant material when it's gone from first lush growth. Let's think of the oat plant. Think of a grain plant. Grain first grows, it's very high in nitrogen. And then it starts to form a seed head, and the stalk gets that first hint of gold hue in it. And the carbon to nitrogen ratio in that plant matter shifts. And it goes on to the order of more like 40-1. That's a fungal sweet spot. And then if you're truly growing grain, it heads up completely and totally carbonizes and becomes straw. But when I'm mowing in the orchard, just as flowers are setting seed, grasses are starting to form seed, I'm hitting that fungal sweet spot, laying it down as a drip line mulch, tying that all together with what's going on in the soil with the roots and the fungi. That's why I call this biological mowing. Another interesting thing about roots and competition, so to speak, other plants. So this is a picture where, for artistic purposes, we've really crowded the trunk. Don't see it that way. Put it a little further out from the trunk. But in an ecosystem where you regularly mow, one of the things that happens is you're favoring grasses because they can grow at that short height and do much better than a broadleaf plant. That in turn stimulates their root growth. And just as the sod above becomes thicker and denser, becomes a lawn, the roots below become thicker and denser. This is why we can have sod farms and roll sod up and move it from New Jersey to wherever. Well, that denser root system of mowed grass produces more carbon dioxide per square foot when roots respire than a meadow ecosystem, where even though it looks just as green and just as filled up, there's a lot more room in the humus. That the root density is not near what it is for a sod. Well, feeder roots of a fruit tree can function in that lower level of carbon dioxide respiration, where right under a sod, they're going to go down much deeper. And in terms of action, in terms of where the minerals we want are most available, that's up in those top several inches of soil. So the choice to grow in a mowed ecosystem is a choice to have problems based on what's going on with the biology. Okay, furthering soil potential. Let's see. I want to make sure I keep a pace to this. So I'm actually at about the 75 minutes, aren't I? Okay, I'm going to go a little bit faster. It is hard sitting here in a room by myself, talking to myself, to know what is really going on. Who am I? But here we are. So orchard compost. Hopefully you all make compost. And when I make garden compost, I am going for a carbon to nitrogen ratio of 25-1. And that's formed by just taking half green materials, green being rich in nitrogen, like grass clippings, like vegetable waste from the kitchen, like fresh manure, which is brown, but it was green the day before, and mixing it with carbon-rich materials, like fallen leaves, like hay, like straw, like soil, like wood chips. And I do a static pile, so it doesn't heat up hugely, but it heats up enough because I pay attention to mixing carbon and nitrogen. And that produces what I call a garden compost. That in turn, so here my wife Nancy making the layers, that in turn, when these piles are ready to go out to the garden, a good half of it I take and mix again with ramial chipped wood. This is sometimes where I use up the softwood material, but hardwood's great too. And that pile is going to sit for 6 to 12 months and develop a fungal element. There you see the white hyphae, because the wood chips, contribute a little more carbon when I'm ready for the more higher fungal phase, but they also aerate the pile. And that's what I call orchard compost. That's what I like to get out in the orchard to replenish the fungal duff. Orchard compost is something that if you're wanting a shot of calcium, let's say, throwing either calcitic lime or gypsum down in August and roughly forking it into a aged pile means that the calcium will be taken up by the compost food web. So when you apply it post-harvest, that particular nutrient is going to be more bioavailable and taken up more immediately. My orchard compost piles, and my garden compost piles, when I'm doing holistic sprays, usually think in the orchard you're spraying and there's fungicides and insecticides and what have you, but I'm spraying nutrients and I'm spraying biology. I'm spraying those fatty acids, and they're good for the compost food web, for soil life, for life. And so I spray my compost piles as part of it. And if you were walking by on the day I sprayed, I might spray you. Who knows? Biological maturity. I like to get compost broken down enough when I mix in the Ramio wood chips so that it's not completely mulch-like when I'm done, but it's rougher. And that's because there's still foods for the biology in a state of decomposition. It's not gooky, it's not raw, but it's going to provide more food for the soil organisms right off the bat than older compost. Another thing to understand about compost, you might read that it will take 2 tons per acre to replenish a orchard for the nutrients that were taken out with the harvest. And I am using primarily MM 111 rootstock and Bud 118 rootstock, and the spacing is typically a 8-foot radius per tree, so a 16-foot diameter allotted each tree. And if I do the math, it turns out that 1.5 5-gallon buckets worth of compost is what I need to meet that 2 tons per acre rate. So that just makes it a lot more, my mind can get around that. My mind does not get around a 2-ton pile. My mind gets around a 5-gallon bucket worth of thrown across the tops of the fallen leaves on the orchard floor. That's my goal. And it's a much more reachable goal than thinking in terms of tonnage. So very, very quickly, we're going to do soil testing. And I'm going to emphasize fertility ratios over more the idea of I want to maximize yield. I want a healthy plant. Where do we find that? Charles Walters, who started the Acres magazine, talked about balanced nutrition as the key to resisting pathogens, resisting insect attack. That's what we talked about with the very first slide, healthy plant metabolism. So soil testing. There's going to be numbers involved. Some people get excited about numbers. Numbers are good, but it's soil chemistry. It's not soil biology. And so I just want to highlight what I look at. I had asked Burl and a few of you, maybe you could get me an Alaska soil test just to get a sense. And I didn't get one, but Rob Bishop sent this picture, and that was all I needed to know. I can work with that. I hear these things about clay and rising soil and silt particles and the challenges of Alaska. But at least for Rob, it's like, this is what my ground looks like. I'm here, I'm with you. pH matters. Getting it in that 6.3 to 6.7 range is where we're going to have the most exchangeable nutrients. So that's a goal, but pH is not the whole enchilada. We're going to talk about that. Organic matter matters very much. Getting it up to 5%, that if you're going to have a bucket list, get your organic matter up to 5%, make that near the top. Phosphorus, I don't worry about too much. I do put some rock phosphate in the planting hole, a pound or two. But once the fungal system is up and running, phosphorus is what it delivers particularly well. What I really zero in on are what are called the base saturation ratios. And not every lab provides the base saturation ratios. These will be shown as a percentage between calcium, magnesium, and potassium. And when I look at this, I am aware of the fact that a little extra magnesium is appropriate in a sandy, low CEC soil because it helps bind soil particles tighter to hold nutrients, where a little higher level of calcium is relevant in a heavy clay soil because calcium helps spread soil particles apart. So I just want to take advantage of that. So these numbers, the ideal, I'm going to see the calcium percentage be 7 times greater than the magnesium percentage. And so 70% to 10%, that's sweet. 70%, 12%, that's sweet. 68% to 12.5%, that's sweet. It's in that range. And the third number refers to potassium. In the sandy soil, I want that magnesium number higher. In a clay soil, I'm going to go for a little bit more gusto on the calcium end of things. This is all written about in the Holistic Orchard and the Apple Grower book. And one of the things, I'm talking these are the percentages, but another very relevant part is, where did you start to get those percentages? And this is where the calcium number, which is usually given in parts per million, is very relevant, because it shows you what your calcium baseline is. So parts per million can be converted to pounds per acre by just multiplying it by 2. So if I have 700 parts per million multiplied by 2, that's 1,400 pounds. I want it to be 2,000 pounds per acre at a minimum, even as much as 3,000, particularly in a clay soil. That's going to help me establish what those percentages mean, what the starting point is. And the choice I make from here is, which type of lime? Do I need more magnesium? Then I go with dolomitic lime. Do I need more calcium? Then I go with calcitic lime. How much of that do I need? This is where you get into the pH number. But the choice is based on those base saturation ratios, knowing which direction you need to push things. The other thing about lime, so if you're just planting an orchard and you're forking the soil, or possibly you're even tilling to do a cover crop because you're changing a certain aggressive grass or some other plant, you're changing the ecosystem over. By incorporating the soil, you get lime a little deeper. And there you can talk of 1 ton or even 2 tons per acre kind of application. But once you plant and you start to get a living mycorrhizal network in place, you're not going to dig it up, because that would destroy it. And you're going to be involved with surface applications. And in that case, I will typically work with a fall application of lime on the order of 400-600 pounds per acre. I don't want to go higher, because it's just too much for the biology to handle on the surface. And I often will use pelleted lime. The pellet, what's used there is molasses, and humic compounds are often included if it's a good lime company. And that helps facilitate the uptake by the soil food web organisms. But I'm only doing that maintenance phase work if subsequent soil testing confirms 3-4 years down the road, I need to do some pH work again. I'm not assuming that I'm doing this every fall. I think many of you understand that. Gypsum is something that I utilize in the spring, ideally applied 45 days before the flowers open. That gives the biology time to incorporate the calcium to take it up into the plant. This is something that you can utilize once your pH is in place, but you're still trying to get your calcium baseline up. And the other thing about gypsum that's really relevant is it has the sulfate portion. And that's going to help balance some of the other cations. But sulfur is also very important in protein synthesis, and sometimes that's overlooked. And I'll get to sulfur one more time. There was research in France that talked about the calcium base saturation ratio compared to the third number, the potassium saturation ratio. And when that's on the order of 20-1, plants achieve optimal protein synthesis. And they were doing this work with apples, referring to scab. And this is about having less amino acids in the plant sap, asparagine being one of those amino acids that scab feeds off of. So what we're doing in the soil when we talk about cations, calcium, magnesium, potassium, we're working on the disease front because we're working with fertility ratios. This work comes out of, these thoughts come out of the work of Francis Charbachot, who was a French soil agronomist doing work in the 70s and 80s. Acres sells this book. But that's the gist of what I would tell you. With sulfur, I do look at that number in particular because I want to see a minimum of 25 parts per million or even as much as 50 parts per million. I have a typo there. That should say parts per million. And again, this is about complete protein synthesis. We're running through things fast now because I'm seeing that I've got a lot to tell you, and we don't have all the time in the world. Another cool thing is that plants can take up nitrogen as nitrate or as ammonium. So when a microbe eats a microbe, one of the waste products is ammonium. And in a less fungal place, the plant is surrounded in the rhizosphere by nitrifying bacteria, which convert the ammonium to nitrate. The plant takes up nitrate, but has to convert it back to ammonium to use it to make those proteins. It's far better if it's a more fungal-dominated ecosystem, because then the rhizosphere is a little bit more acidic. Nitrifying bacteria don't thrive, and that in turn means the plant has more energy to do the whole metabolism thing. You know, this is one of those details. You don't have to know all this stuff. You can listen to me, goes in one ear, comes out the other. But you just need to understand, yeah, if I make it fungal, things are going to be good. You know, this is just yet another part of that storyline of why we're going about that. And when nitrogen is in the nitrate form and plants don't have as much energy, we've known for decades and decades that that's what leads to more disease. Anyone growing a pear, you go dump a couple wheelbarrow loads of fresh manure around that pear, and it is going to have disease problems galore, including fire blight. So this slide is to remind me to say photosynthesis. Let's make photosynthesis efficient on the front end of things. And that's where the trace minerals play a key part. So when I feed my sheep kelp meal or add azomite clay as a layer sprinkling on a compost pile or in a planting hole, this is all about that range of the different trace minerals, iron, manganese, molybdenum, copper, iron, just having some of that in my orchard ecosystem, because those are used as enzyme cofactors by which plant metabolism launches into being efficient. Rock dust can be valuable there as well. This slide, I'm just pointing out to you, you plant a tree and your immediate concern is more like a 3 to 4 foot radius. You might do soil amendments, you might have some wood chips, and you're starting to build that fungal duff. But as the tree grows, you might be doing the gypsum, you will be doing the gypsum further out. You may be adding a sprinkling of azomite clay or whatever your trace mineral sources are further out. You're now into haphazard mulching. The fungal duff itself is expanding. But immediately, you don't have to buy every amendment under the sun. And eventually, you also don't have to, because we're going to work with organic matter. We're going to work with biology primarily. This word, rhizophagy, I have to be super quick now, but we have just gotten pictures, microscopic pictures of the fact that feeder roots, they don't just absorb soluble ions, they actually absorb whole bacteria. And this is one of the primary ways by which trace minerals are put into the protoplasm of the plant. Those bacteria then are somewhat emptied of their riches and sent back out into the soil where they pick up more riches. But this is just like this whole new construct of understanding that plant nutrition is a whole lot deeper than it's been presented for these last 100+ years. This whole NPK thing, it's much more beautiful, much more involved. The link between plant and soil biology is so complex. What Frank Egler was saying. For me, again, going back for a simple way of expressing that, I'm going to have a lot of nutrient density in my fruit if I support a lot of life density in my soil. That's kind of my overarching management theme. Create that life density in the soil by doing fungal things, by providing organic matter, touching base with some trace minerals, but more than the soil chemistry, it's the soil biology. So taproot fertility. This is really important construct, understanding that a root that goes down and deeper to different soil layers brings up mineral nutrition that in its leaves and its stalk puts that mineral nutrition on the surface of the soil. In permaculture, these would be known as dynamic accumulators. And this is a picture of chicory, which is known for accumulating zinc. And you can find lists of these things. For me, it's the more diversity, the more plants I can support in that ecosystem around the tree, not immediately at the trunk, but further out and in the sunlight in the aisle, the better the whole system is going to hum. So one of those plants for me is comfrey. Bigger leaf system, room in the humus for feeder roots. Right after the apples are done flowering, the bumblebees move to the comfrey blossoms. You got to support your bumbles throughout the whole season to have that pollinator force. Comfrey leaf accumulates calcium, rich in calcium. I harvest this. We harvest it both as an herb for us, but I also ferment comfrey leaves as one of my fermented plant extracts for foliar calcium. In the fall, letting comfrey stubble and other plant stubble in place, that's often where the beneficial insects will winter over. We even dry comfrey for our chickens because that's calcium for their eggs in the winter months. We don't live at the ocean. We don't have oyster shell unless we buy it. So I want to see all these different plants. Here in this picture, there's some daffodils. Not just because they're a touch of beauty in the spring, but because voles don't like daffodil exudates. And so they tend not to settle around a tree, which is surrounded, has some daffodils in the soil ecosystem around it. That is not to say don't put vole guards around your trunks when snow comes, but it makes it a less of a vole place. And here you see the woodsy mulch. It's a little more open right under the tree. You get further out, the grass is thicker. There's different plants growing there. So nitrogen accumulators, there's plants like the red clover. Yes, legumes do this. But then there's also shrubs like Siberian pea shrub or buffalo berry that fix nitrogen. Those in turn, those shrubs might be planted very close to your fruit trees, but they can be managed by coppicing so that they don't become the dominant overstory, but rather a smaller plant fixing nitrogen where tree roots can interact with the roots of that plant. This is a picture, this is a bad picture, deliberately chosen. Permaculture, the idea of chop and drop. And people will say, yeah, I grow comfrey and I chop and drop it. Well, this has been thrown right against the trunk. I want that good stuff to be decomposing a little further out than that. But I also don't cut comfrey. Comfrey is a living mulch plant to me, provided that you are growing one of the Bacchian cultivars that doesn't set fertile seed. If you're growing the European comfrey, sowing it is important because if it sets seed, you may end up with a very undiverse ecosystem where comfrey dominates everywhere. I've seen that before. But coppicing those nitrogen-fixing shrubs a little further out, and you may not have a chipper. Remember those ideas of mini hugelkultur and throw some old hay over it. Put it in a low spot. Put it between the trees and let it break down over the course of a few years. There's different ways to achieve these goals. Coppice management, you can have those bridge trees a lot closer to the orchard trees than you think. And I know we have the thing going about your aggressive alder roots. But this is how I work with alder and willow, not right next to the tree, but I'm getting ramial chipped wood. But if it was right next to the tree, it doesn't have to become taking the snow cover. Again, those soft hardwoods have the 12-foot long explorer hyphae, which in turn work with bacteria along the length of the hyphae, which produce organic acids to bore into bedrock to bring minerals back to the plant. In this world of electron microscopy, we can actually see what this looks like. The fungal hyphae in H shows you where the bacteria are. That's an X-rated picture. The fungal scene is an X-rated scene. So here I am laughing at my own joke in my own room, and you're all up there in Alaska wondering, what are we doing with this guy? But we'll soon see each other, which will be a good thing. And, roots reach far. That interaction between alder and apple, it might be direct, or it might be because there's pasture, passage plants, the lawn, the meadow plants in between those ecosystems. Lupins fix nitrogen, which grow quite readily around here. I suspect in Southeast Alaska, you see lupins as well. The beneficial accumulators, we're now talking about the small flowering plants, things like buckwheat, things like sweet cicely, Queen's Anne's lace, any of the umbelliferous herbs. They provide nectaries for adult insects whose larva is going to take care of situations like this. So this is a young apple tree. The aphids certainly have an edge here, but this in turn, the plant is signaling, hey, ladybugs, other beneficials, come here. It's a feeding ground. This is the larva of a scyphid fly. Scyphid fly are those hovering flies that like composite type flowers, things like hardy marguerites, daisies, and their larvae eat 40 aphids a day. They look like dragons. You know, we're entering the realm now of things we don't see. But the way nature does this, it's not like one beneficial takes care of everything, but a pirate bug is working here. A crab spider is hanging out over a pear blossom and aligns its stripes exactly with the pear, the pink and white of the pear blossom. Sometimes it catches a pollinator, but sometimes it catches a problem bug. This is a picture of a little tree frog. This is in Australia. Tree frogs, toads, are very relevant in my ecosystem because they eat Cuculio, which is an insect you don't have, but who knows how our world is going to change. But again, it's all about diversity. Here's a wolf-spired spider living in the ramial wood chips at the base of the fruit tree in the fungal duff zone. Well, any insect that drops from the fruit, in your case, that's primarily going to be codling moth larvae. In my case, it'd be also Cuculio, an apple maggot fly, European apple sawfly. These are insects that pupate in the soil. Well, having a line of defense right there before they get in the soil, beautiful. The birds, another important piece. Simply by having, let's say, pie cherries and apples in the same ecosystem, the stone fruits have extra floral nectaries that support lady beetles so that by the time the aphids show up on the young apple trees, that part of the population has an edge to go forth. This is a book I like a lot for the plant knowledge of who's going to be drawn to which plant, how do you create a more diverse ecosystem. This was put out by the Xerxes Society. In permaculture, we talk about stacking functions. I've been just spouting off all kinds of things, repels voles, fixes nitrogen, works as a living mulch plant. The more plants you have, the more these different functions are taking place. Planting in clumps, thinking about something in bloom throughout the season for the pollinators. All of this is so relevant. Yeah, this is a picture of an Asian pear orchard. And I think I'll stop here and we'll go into question and answers. But in that picture, you know, you see mountain mint, there's some comfrey, there's all sorts of plants. It's a little bit dense around the tree, but this is that kind of ecosystem. A little more mulch around the tree would be good for early growth, making it a little less of a vole habitat. But this model of a wide, broadly based plant community, working with as many as 50 different species of mycorrhizal fungi in a well-mineralized soil, that's all about making healthy plant metabolism happen, photosynthesis more efficient. So sugar exudates are sent to the root to trade with the biology. It just gets better and better and better. So now let me find my way back to you. And maybe we'll see Burl.
Yeah.
And
okay, I am
there we have him.
Oh, nice. Thank you, Michael. I got a question here from Jen Landry, and I'm curious about others in Southeast, at least according to our soil test results here in Gustavus. We have high calcium and low magnesium. Langbionite is what I use to balance this. Any contradictions for using langbionite in an orchard? Did we discuss specific target calcium levels and magnesium levels for the orchard? We did, versus a garden. And I'm guessing this is not specific to my land, as I know other farmers in Southeast Alaska also use langbeinite? There.
So langbeinite is sulfol mag, and when you have a need for magnesium and potassium, you're also going to get that sulfur piece. And I will use that as a early soil prep amendment in working with cation balance when the scenario is right for that. Another way that sulfol mag is used, even in soils where it's not drastically off. This is an idea from Carrie Reams, who was an early eco soil advocate, who talked about coming in every 10 years or 5 years with a rate of 100 pounds per acre of sulfol mag in the summer months when potassium is actually taken up. So from July 15th to September 15th. And that this also seemed to somehow help get copper into the trunk tissues, which made bark tissue more flexible, which helped with winter cracking. So I can go off in obscure directions. But what I was saying in terms of base saturation ratios and the Albrecht approach, which is what that's known as, 7-to-1 calcium to magnesium, if it's possible. It won't be with all soils. That certainly applies to garden soil. It's not different. It's the same notion of a fungal dominated ecosystem pretty much applies to most garden plants as well. They have a connection with mycorrhizal fungi. So I'll leave that at that and go to next question.
Let's see. I don't have another one in the chat. If somebody would like to ask a question, you could unmute and fire away. Okay, here we go. I'm building a raised bed. Oh, no. Okay, here it is. This is from Whitney. I'm building a raised bed this spring. I have a soil test for the fallow soil in my compost. Michael, want to look at them before I want to look at them before I start. Well, they're asking you to look at your soil, at her soil test. Darren Snyder with the Ag Extension in Juneau might be a good one there for Whitney to look at your soil test. That would be probably better, more local, and have a little more local just knowledge about that.
Well, I could speak to that briefly here, I maybe Whitney is also offering, because I know Michael requested to kind of like see examples, and maybe that was specifically just to this talk, but I don't know if that was her motivation. But there is so much to this whole holistic management of the orchard and the soil environment that, the honest truth is, I'm not the epitome of an expert in this specialized, field. And I, as much as I wish as I was, I love that the sharing that's gone on here. I very much am happy to have the conversations about what's going on in Whitney's soils, and we can, that's part of this whole project, is to try and have some on the ground demonstration and experimentation in this field. And by developing the orchards there in Haines for this purpose, we're hoping to be able to do this. And I'm wondering a few things along this line. I don't want to take up too much of the floor, but when we're talking about the biological activity within a soil, I think, Michael, it may have been the last conversation that you were leading here, presentation, but mostly it seems like the labs offer that we can test how much biological activity is there, and so that's our kind of like thumbnail. Well, yeah, there's just a lot of biology going on, and whereas the conversations go so specific, especially when we're talking about what types of mycorrhizal fungi are included in the inoculants and such. So there is there's just so much complexity to it, but I would love to be moving forward. We have our lovely steps that we've taken with for to reduce it, but of what Rob Bishop and Blythe and Rob Goldberg and others who have some decades on us here, fortunately, to build, that maybe we could do some more moving forward with sampling their soils and correlating that with their practices and just trying to move the body of knowledge forward. Because honestly, as an extension agent from the University of Fairbanks, we don't have a whole lot, and I'm just putting this out there, we don't have a whole lot of body of knowledge in this. And so that's where we're all trying to grow together in this, Southeast environment and to do this. So I'm on board with us. I don't want to, underemphasize that, I do have a lot of knowledge of kind of what's going on in the soil and all, but when it comes to these complexities of relationships, there's just so much to it that experts such as Michael, who have been really focused on this, carry forward.
I'll just say something quickly. It's just that, part of our project, which is funded by USDA, is if people in the Haines area and the Chilkat Valley area are seriously looking at an orchard, which in our case involves a fence, because we have bears and moose that are really a problem for long-lived fruit trees. And if you're not interested in fencing, well, we're not interested in testing your soil. But if you are interested in fencing and getting serious about it, we can do that. We'll come take that sample, maybe do a quick jar test, but also send off a good composite sample to a lab. And that's something actually I'll be sending out some information about that. So if you're serious about that, contact me, please. The next question is Charlie and Sally Pierce. Regarding mineral ash, here in Southeast Alaska, many of us use wood stoves, often burning mostly softwood, that is conifer. Would you use this as any kind of an amendment in your orchard?
So as far as wood ash goes, that can have quite a varied profile of the minerals that are in it. And we're not going to test what's in our wood ash, so we don't know per se. One thing that'll be high is potassium. So if you already have high potassium, remember that 20-to-1 ratio between calcium and potassium. No, I don't think I would use that. Some wood ash can have high boron levels. So a little bit is okay, but you can't overdo it because you don't actually know what's in there. So yes, I utilize wood ash. I will sprinkle a dusting on a compost pile sometimes during the winter. I might use it more often on my field edges or even in the woods around sugar maple trees, because I'm not going to otherwise be buying something. So I share the wealth, so to speak, out there. So it's not a troublesome material, but it's an unknown in terms of really getting into that finer chemical balance. And sometimes when we don't know something and we overdo it, we might push something into excess, and an excess can be as much of an issue as a deficiency.
Okay. Mardell Gunn, who lives up near the Canadian border and has kind of an unusual soil profile. I'm an unusual Alaskan to have alkaline soil, but is there any indicators in fruit trees of too alkaline that I can watch for, or for others too acidic? Mardell, if you want to clarify that.
Always have to.
All right, man.
I was going to say, I always have to go to the books to look up mineral deficiency or mineral excess symptoms. But typically, look at sulfur, and not just in the sulfate form as from gypsum, but maybe you need some sulfur pellets to help start shifting things downward in terms of pH. But then you have to also know what that sulfur level is so that you're working with that. It gets tricky when we're trying to work with soils that are out of the ideal range.
Gustavus soil from Whitney Rapp came back 7.6 to 7.8. Okay, Donna Ray. We haven't gotten to get your new book yet, but I do have your Holistic Orchard, love it, and YouTubes that feature you. We know that you would do your orchard work Just trying to read this. And we know that you would do your orchard work based on the tree stages, not an actual calendar date. But do you have an overall comprehensive calendar of your orchard tasks? That would be great. Thank you for your talk.
Well, there was an early version of orchard calendars in Apple Grower and in Holistic Orchard. Now, I also, at this point, will say the website, groworganicapples.com, it's a grower network. And between the newsletters and the discussion forum, there's a search engine on the bottom of the pages. You will find, both updates and new thinking. I do know, because I tell people about this, the June 2018 newsletter, I somewhat tweaked the schedule that I put out in the book, because, you have 9 more years of learning and experience, and you see this is a better way to explain it. This is a little better way to do it. But the website is basically my way of kind of keeping people updated on how things are going.
See, I got one from Jen. And I know you have said you don't know how long these talks will be available. Oh, she's talking to me. My farm season is revving up and I may have limited time. Okay, Jen, I'm going to keep these. I'm going to make sure that we save these. Now, these will be available. These will be available. The Zoom will be recorded and permanently available on the Chilkat Valley Historical Society website, I'm pretty sure. But they're certainly going to be available for quite a while. That is this is the 6th program that we've recorded. Okay, let's see. Jen Landers again. Gustavus potassium low and boron low. We definitely use wood ash, but our reason for caution is that too much pushes our soil more alkaline when we don't need more alkalinity. Yeah, at 7.6, I would say that is true. Okay, Rob Bishop has a question. Cherry cracking is a problem here. Is there a remedy with soil biology?
Okay, I'm going to go I'm going to get involved with this one. So cherry cracking, I have certain apples that crack. My pie cherries, I don't have cherry cracking. So for me, the whole calcium and silica piece is important. And I'm going to kind of delve a little into foliar nutrients with this answer. So yes, we're working down at the soil level, adjusting pH, getting calcium there, using gypsum, all the things we talked about earlier. I did say something that was important when I was showing you the fungal curve, in that I talked about that early spring spray of basically bacterial stimulants. That was that mixture of the whey proteins in raw milk and the blackstrap molasses, carbon sugars, energy, activated effective microbes, because I want those organic acids and enzymes. But what I'm trying to do there is, at that moment in the presentation, I talked about how this is kind of acts as a stimulant to mycorrhizal helper bacteria, the ones that make the enzymes and organic acids that dissolve mineral rock so the plant through the fungi can take them up. But what I'm also trying to do there is give a nudge to the facultative organisms, not the outright aerobe, those bacteria that, rather than oxidize important trace minerals. So right now I'm talking specifically about things like copper and iron and manganese. If those minerals stay in a reduced form, the plant can work with them. And often that is not the case. And we don't know that through soil testing. We know that through plant sap analysis. Now, I could talk about foliars to help with that, but this is a piece that organic growers, biological growers have been overlooking. And, when I do a spring 2 spray and the spring 3 spray, yes, some of those fatty acids are dripping down to the soil. Some of those organic acids from the EM component is part of that. But in terms of getting the trends of the nutrients in the plant sap right, and this relates to cherry cracking, it relates to something like my St. Edmund russets cracking. It needs the boron, it needs the iron, it needs the manganese to work with the magnesium, to work with the calcium. So I work with some foliar sprays, particular nutrient applications at certain points.
Oh, God.
That launching of the season with the ground spray, the bacterial stimulant spray at green tip, and knowing that the next couple spring sprays are also going to drip some of these good materials down there, that's highly relevant. And as far as the biology piece goes, you know, we're kind of going in a little bit the advanced direction here. We could do like a whole workshop on this. So I'm spraying effective microbes. That's mostly lactobacilli and different yeasts. I am also using a bacterial formulation from Tanio Biologicals down in Washington. And there they have some of these other facultative bacteria, these reducers, in that mix with photosynthetic bacteria. So that also goes into that first spray of the spring season on the ground to make sure that I'm nudging the species that are going to really help with important nutrient uptake for the next couple months when the plant really is counting on those nutrients. And even though it seems very distant from the point where cherries actually crack, it all is of one piece.
Okay, let's see. I'm going to get a question from Donna Ray. And the scion wood on our Chinese apricot died, but the rootstock survived. Do you think it will make edible fruit?
Well, my answer is I have no idea. Something like a peach might cast a fairly decent peach. Your apricot may not have even been grafted onto apricot rootstock because prunus is interchangeable. So totally no idea.
Okay, Charlie and Sally, we have an area full of wild rose roots. Are these beneficial to an orchard, or should I continue to eradicate them in the near vicinity?
So a little bit of something is always like more diverse. But when something is very aggressive, it can become problematic. So with those roses, you know, somewhere in the ecosystem, you know, certainly they're related to fruit trees. They're going to share some of the mycorrhizal fungal piece. They're going to play a role with beneficial insects that has value. But in terms of like getting too close and dominating the understory, the aisleways around your fruit trees, probably not what you want. So mowing that, changing that dynamic, pushing that plant back. This is not unlike the question last time about this Alaska alder that one of your growers was talking about in terms of just the aggressive root dynamics and putting barriers in the soil to keep that at bay. I'm not familiar with that. I have some willows that are a little bit more aggressive, and I do find that mowing in the zone around my fruit trees, it changes their prospects, and other plants are going to thrive in there. So I wouldn't want roses going wantonly wild, but I wouldn't necessarily go out of my way to get rid of them.
Okay. Larry Landry, I don't quite understand your question. Could you come on? Yeah.
This is me. I confuse myself trying to type it. It happens all the time. And first off, I would like to say, Michael, I feel your pain speaking to a computer alone in the room. I think we all do.
It's an amazing thing.
A question I have is, I've often gotten soil from under alder in an alder thicket and used that as my mycorrhizal base. Do you think that's enough, or that I should definitely be buying the other stuff too?
Okay, so the alder has both an ectomycorrhizal component and an endo. So it has some players that are relevant to fruit trees, but it doesn't have nearly all of them. And any of the ecto part won't work with your fruit trees as we currently understand things. So I would mix that up. Do you have to buy inoculum? Not necessarily, but I would go to some place where there's some raspberries and goldenrod, and you know, even in the forest, but forest edge. Think forest edge. You get more diversity there. Even though tree species have ectomycorrhizal component, there's usually half of the fungal thing is endomycorrhizal, 50% on average, even in a forest ecosystem. So going to the forest edge to where some other plants other than just the alder grow is going to get you a few more species. And I would play with that.
Okay, thank you.
Here's an interesting one from Rob Bishop in Hoona. We have encountered healthy rogue apple trees growing along a muskeg peat bog. Do you know of any successful orchards grown in such soil? Which I assume means a very high organic fraction and fairly acid soil.
Right, I would too. You know, the thing about a peat bog, if you think about it, there's thousands of years ago, lots of softwood material being broken down by the brown rots I talked about. And what's left behind, because it's not a deciduous environment, there's no white rots to make the humus. So you're left with this peat. And if it's compressed enough, you get down to the humates, and you can buy humates as part of a energy source for when you plant a tree. As far as these apple trees go, you know, going back to the last question, now that I know that you have feral apple trees here and there, that also could be a great source of the mycorrhizae you want for your fruit orchard. Not necessarily the peat bog element, but if feral apple trees can be found, that could be one of those wild sources. And you don't need much. You know, you bring a quart of soil from the roots of a wild planting area, and you can distribute that among 3 or 4 young trees. Some spores will be there, and it just takes a launching, so to speak. But as far as those apple trees, okay, they're there. Are they healthy and robust? Are they buried under softwoods? As far as sunlight goes and kind of just existing, those pieces would be relevant in terms of trying to extrapolate, is there a lesson to be learned from this bog soil situation for those apple trees? So we need to see more, I think, to talk about that. But that's great. I'm glad to hear there's feral apple trees, despite the bears.
Okay. Brenda Krause in Juneau, Alaska. How does high iron in cold, wet soils affect mycorrhiza and nutrient uptake?
The iron is an interesting one. I have high iron in my soils here, but I do not have good iron levels in my plant sap analysis. Iron is one of those elements that is readily oxidized. So think rust. A plant cannot utilize iron in the rust form. So that's where the reducing organisms, the bacteria I was talking about, come into play. So even though you are seeing high iron levels on your soil test, 9 out of 10 times, you're not going to see good iron levels in your plant sap. And this is a function of those reducing bacteria getting iron to the tree in that form. So I talked about stimulating those bacteria. Here's another interesting thing, and I'm just learning these kind of tales. Cereal grasses tend to be really good at maintaining populations of iron reducing bacteria. And so if you have that open ground under your apple tree, you know, not completely open, it's just here and there, and you did some wood chips like I showed you in that picture, which I said cruise control. And there's a pocket here and there, and you throw a small handful of oat seeds to sprout. Those oats will start to increase the populations of iron reducing bacteria in the vicinity of your fruit tree, which is going to help your fruit tree through the siderospores that those bacteria produce, get iron in the right form as well. I love that we're finally articulating soil chemistry through the jaws of biology and plants, because that's really where the action lies. It doesn't, as much as we can buy a bag of gypsum or a bag of calcitic lime or what have you. That's just such a small portion of the story. And it's so right to be finally talking more about specific biology and specific plants that are going to help with specific needs of fruit trees.
I have a question for you, Michael. We did some soil testing on a piece of property that's here in Haines. It's called Henderson Farm, and it was used. Well, anyway, it has some very high numbers in organic, and 3 of the 4 samples were over 40% organic. In other words, and it's high in acid, so it's indicative of what in our region we call muskeg, which tends to be very high organic or peat-like. And what do you suspect might be any challenges there or limitations for its use as an orchard?
I would think, I've just started reading some works by, I'm not quite sure how to say their names, but they were writing in the early 1900s to 1957, the year I was born. And they talked about soils with 65% soil biology, organic matter, and like 15% minerals. And that's like nature's goal, so to speak. And we haven't seen that. We've depleted soils worldwide in so many places. So in one sense, I'd be really attracted to working with that soil because you have that organic matter edge in this huge way. But I don't have experience at all, other than knowing that I've read there's this ideal soil, and getting the right biology and a diversity of plants growing there, it may all really take off. But that's not something I'm probably going to learn here in northern New Hampshire. But one of you in Alaska could be the one who trips the lights fantastic on this one.
Okay, let's see. I got one from Rob Bishop. You're just killing it here. Okay, here we go. Can we make EM1 inoculant for sprays? If so, where in the wild would you find it? Note, we have lots of kelp in Hoona. We have also cows and a lot of fish. Sometimes these spray items are hard to, I'm trying to get you there, Rob, hard to get in rural Alaska. So can we make EM1 inoculant for sprays? And if so, where in the wild would you find it? We have lots of kelp. Hoona has cows and lots of fish. Sometimes these spray items are hard to get in rural Alaska.
Right, in general, in buying spray products, you have to think ahead. You can't, that week I need this, and run down to the local supermarket or farm store and necessarily get it. So I appreciate that aspect as well. I also am doing a lot of investigation into homegrown mineral formulations, in part just because of even if you can get it by ordering early, it's like $70 shipping for 5 gallons of this product and another $70 for 5 gallons of this. And that gets old fast. So last spring, I believe it was either last winter or spring, I wrote about the idea of using cider lees. So the settled solids, when you ferment cider, making hard cider, that those are not only the dormant yeast bodies that have settled, but there's a huge amount of lactobacilli in there. So feeding cider lees, that blackstrap molasses, would be a piece of what EM1 brings into play. And the most important piece being those lactobacilli and the yeasts. So I'm playing with that and learning. They certainly consume the blackstrap molasses. So something's in there. I think it's a good something. I don't have the money to analyze everything that I do. So we enter into the realm of intuition and imagination. Similarly, in Korean natural farming, you'll read about harvesting lactobacilli, or people will do that with a yogurt culture. And, if you start thinking about the microbes that are in there, there's a few things you can do. And you could create a lactobacilli culture and add the yeast component. You could even add some of the nitrogen fixing organisms used in the Tanio product, because those are sold as some kind of animal feed supplement. So that's one thought. The kelp, I buy a 44 kilogram box of dried soluble seaweed. I don't know how you as a home formulator make seaweed soluble, but you could ferment it and use the liquid. People certainly do their own fish formulations. And maybe the further you live away from people, the better that will be for you in terms of creating that. So yes, I am a big believer and proponent of making some of your own biology and nutrient formulations. And I think we're just on the cusp of opening that door even better and giving people more exacting details. So that's actually what I am working on and very excited about.
Nancy Berlin has a question. We have invasive ranunculus buttercup, and that's kind of taken over our orchard. Do you have any suggestions? And is that, as far as eradicating that or dealing with that?
So my one, I'd want to look up buttercup and understand it more. I just have very limited amounts, so that's not something I've applied myself to. If I wanted to change that part of the ecosystem, sheet mulching holds a lot of appeal. You lay down cardboard and cover it with wood chips at its simplest. You could get involved with compost and some other mineral elements as part of that, but you smother it, and then you try to find other plants that maybe compete with that buttercup's return, like comfrey. That would come to mind. Ajuga is a low-growing ground cover plant. Some of the mints, they may or may not, I don't know. I find that, again, with the Ramia wood chips and the pocket approach, I have kind of an openness and a looseness to that soil that the plant community doesn't totally fill in the course of a few growing seasons. And also then the tree structure itself helping to shade it. I think you can start to shift things without totally going in and ripping out the buttercup and disturbing it. I mean, that also may be the approach that you take in your aisles, and you do a particular type of cover crop after a shallow tillage, and you deplete the root reserves of the buttercup, and then another plant grows there and gets established. But those are all the kinds of dynamics that go into changing the plant cover that I think about.